All right, so today we're going to review the section 6.5 so that you remember. It's been a couple weeks since we dealt with this. Okay, so first, whenever we add or subtract fractions, what is the first thing that we need in order to add and subtract fractions? How about, let me pick somebody at random. How about, okay, Eric. The question is, when you add or subtract fractions, right? You need a couple of things. First thing you need is what? In order to add or subtract fractions. Oh, okay. Let's say I give you two fractions, or I don't have to give you two. I can give you three fractions to add or subtract. What do you need? No. When you're adding and subtracting fractions, you forgot everything? Okay. Uh-oh. Who could help Eric? How about Dana? Can you remind him? What do we need, Dana? Common denominator. You guys remember? LCD. So we need LCD first, okay? So write this down. And in order to get LCD, remember we had to factor the denominators. You guys remember that? Right? If you don't factor the denominators, thank you. If you don't factor the denominators, it's very difficult to figure out, right, what the LCD will be, right? You guys remember that? So we'll be doing some of those later, okay? We'll do some examples. But in order to find the LCD, that's what we had to do. Factor the denominators, right? And you list all the factors, right? And we choose the highest exponents. You guys remember? Right? Because both of the denominator has to go into the LCD. So that's the first thing we need to do. All right. And secondly, after we found then our LCD by factoring the denominators and listing all the factors and choosing the highest exponents of these factors, another thing you got to be careful is change everything to addition. Okay, because can I tell you, you need to change everything to addition by using the definition of subtraction, because there are many times where people will make silly mistakes, right? When they don't change things to addition, people make silly mistakes. For example, let's say I gave you something like this: 2 over 3 minus 5 plus 6x over 3. Okay. You see that the main subtraction in the middle, right? Subtraction between these two fractions. When you change this to addition, does the 5 only becomes negative 5, or do we need to change that 6x also? 6x. You guys remember? If you don't do that, so because it's really 2/3 plus, really, right? Change the subtraction into addition, right? That's by definition of subtraction. Then negative 1 times whatever that's next to it, right? So you have to distribute this negative 1 to both of the terms. Right? Many times people only will write negative 5 plus 6x. They'll be wrong. You guys see what I'm saying here? So I need to distribute this negative, or the negative 1, to both of the terms on the numerator. Who could tell me what I get when I do that? Sammy? So when I distribute this negative 1 to the numerator of the second fraction, what do I get? On the numerator I get negative 5 plus 6x or minus 6x? Minus. You got to distribute. I actually wrote it as I wrote it underneath. Negative 5 plus negative 6x, right? Now, do I need to multiply the negative to the bottom, the denominator? No. Why not? What does negative 1 really mean? Negative 1 is really negative 1 over 1. So what's 1 times 3? 3. So you don't write negative 3 on the bottom, do you? You see what I mean? So really think about that, right? Negative 1 is really negative 1 over 1. You just distribute that to the numerator. Some people, multiply the negative 1 to the denominator too. That'll be wrong, because that will mean that you're multiplying negative 1 over negative 1, right? That's not what we're doing here. It's negative 1 times this whole thing on the right. You see that? Okay. Okay, go ahead and finish up. See what you get. Now that we have a common denominator, I'll wait. Okay. See what you get. I'll wait here, guys. Everybody go ahead and try. So then, who could tell me what to do next? How about Tajwar? What did you get?
The answer?
No, what do I do next?
Okay. You add 2 to negative 5, you get negative 3 plus negative 6x. Then you divide everything by 3.
Oh, hold on. Okay, so that's good. So we add all the numerators. Now that we have a common denominator, right? Does the denominator change to something other than 3? No. That's why we have a common denominator, right? When you add two fractions, denominator stays the same. All we have to do is now add the numerators together, And we get, you're right, negative 6x plus negative 3. Notice I wrote it as a standard form. We like things in standard form, right? And at this point, algebra is correct. We could actually simplify. Thank you. So what we need to do is, could I just cancel out 3 and negative 3 only? No, that would be wrong. Remember, whenever we cancel things out, right, you have to do something. What can we cancel? Can I cancel 3 and negative 3? No, right? Before you cancel, you should always factor. You guys remember? How do I factor the numerator? Is there a way to factor the numerator? Because that's what you have to do. Because people just blindly just cancel out 3 and negative 3. That'll be wrong. You have to factor first in order to simplify. But what can I factor up here? Bella? Do you see? In order to cancel things out, I need to factor something from the whole numerator and the whole denominator, right? Can I factor the numerator somehow, Bella? Do you have any? How? By 3. Or I could factor out a negative 3 if I wanted to, right? Could I factor out a negative 3? Is negative 3 a common factor? And yes, you can. Then, once you factor something out, then you could cancel, right? You guys remember that? Don't just cancel, right? So the only time you could cancel is if it's a factor of the whole numerator or the whole denominator. Because when you cancel things out, you're dividing top and bottom by that number, right? So you can't just, right, cancel those out. So can I rewrite this as negative 3 over 3 times 2x plus 1 over 1? And what is negative 3 over 3? Negative 1. That just becomes negative 1. And then I could distribute this negative 1, because you wouldn't leave it this way, would you? If this is, so I was simply distribute that and get negative 2x plus 1. Does that make sense? So how many forgot negative 2x negative 2x minus 1 as the answer? Good. If you didn't, go ahead and ask your group and see if you can figure this out. I'll wait. Go ahead, everybody try. So now, any questions? Were you able to figure this out with your group? So the third thing I want to say is this. If you want to cancel something out, factor, then simplify. Does that make sense? You can't just cancel things out just because you see the same number or something, or multiples of the number. You have to factor first, okay, if you want to simplify. Because you have to, whatever you're simplifying, right? When you cancel things out, those have to be the factors of the whole numerator and the whole denominator. Does that make sense? Is this negative 3 a factor of the whole numerator, guys? Hello? Is this negative 3 a factor of the whole numerator? Yes. Yes, it is. It came from the whole numerator, negative 6x plus negative 3, right? Negative 3 was a factor of each of these terms. That's what I mean by the whole numerator, right? And of course, there's only one number in the denominator, 3, right? So those we can now cancel, simplify, right? And we know what negative 3 over 3 is, don't we? That's negative 1. Do you see how we do that? Don't just blindly cancel things out, right? That'll be wrong, okay? Right? Because when you're canceling things, thank you. When you're canceling things, you're really dividing the top numerator and the denominator by that factor. All right. This is a nice sort of a review, okay? So let's do some examples. Let's start with some easy ones, and we'll get to the more interesting ones later. So before we do those, let's just review. First, we have to find our LCD by factoring the denominator. Second step is changing everything to addition, right? Then third step, after you've added everything, what should you do? You simplify by what? You simplify by factoring, then simplify. Does that make sense? Factoring the whole numerator and denominator, then see if you can simplify. So let's start our first example here. This one is very simple. 5 over n minus 8n. Everyone should be able to do this without much problem. Go ahead, everybody try. Okay. So this example 1, very simple. We already have LCD, right? Which is n. All we have to do is subtract the fractions, right? So what do we get here? How about Carly?
Oh, I got negative 3 over n.
Negative 3 over n is correct. Isn't that what we get? Because you get 5. I changed it to addition, right? And of course, 5 plus negative 8 is negative 3. How many forgot negative 3 over n? You could So you could rewrite this as negative. Oops. You could also write it as negative 3n. Same thing, right? Negative 3 over n like this. Any question? Either way, it's fine. All right, pretty straightforward. Let's look at example 2. Again, we have a common denominator. It's very simple, very nice, right? 4y over 9 minus 3y minus 1 over 9. And notice I have subtraction again in the middle. And should change it to addition, right? Go ahead, everybody try. All right, so who can tell me what to do first? How about Claire? What should I do here?
You
distribute not distribute, but you change the division sign to multiplication, and then you change the 3y to negative 3y plus 1.
Division sign? Oh, you mean
Sorry.
you mean subtraction?
Subtraction
That's
sign.
right. So tell me what to write. 4y over 9 stays the same. Then what?
Plus negative 3y plus 1 over 9.
Exactly. And that's plus 1 is because you're distributing the negative 1. That's what you're telling me. Okay, did you all see that, guys? No one wrote this as negative 3y minus 1, right? That'll be wrong because, right, you're changing this subtraction, that's an addition, and you have two terms on the numerator, right? The whole thing becomes this opposite. Yeah? Okay, so you all wrote negative 3y plus 1, right? Because you distribute the negative 1. All right, then next, what do we do? Now that we have a common denominator, Lindsay, what do I do here?
Now you can like add the two.
Right. Two numerators together. What do I get when I do?
I got
So I get this 4y plus negative 3y plus 1 over 9.
you get y plus 1 over
Y plus 1 over 9. And that's all you could do, right? Could we cancel something out here? Can we simplify more? No. You can you factor the numerator at all? Can you factor the denominator? No. So that you're done. That's all you could do. Easy? How many people got y plus 1 over 9 as the answer? Very good. Easy? Do you sort of remember now things that you sort of forgot, right? All right, here we go. Let's move on to example 3. Okay. Okay, I like this example 3. I put a star on this one because you'll see why in a minute. I got 5 over 2y minus 1 minus 2y over 1 minus 2y. Okay. It looks like we don't have a common denominator, do we? We do? Kind of, not quite. So let's do this one together. Okay, so I got 5 over 2y minus 1. That's good. I don't like the way the second fraction is written. How come I don't like that second fraction? Especially that denominator. Dakota, how come I don't like the way it's written, you think? Yeah, it's not in standard form, is it? So we need to have things in standard form, right? That way it's easier for us to see, right? How to get, it's much easier that way. Okay, so tell me what to write, Dakota. So the first fraction stays the same. Let's change it to addition. Plus 1, negative 1 times, correct? What do I get? 2y over? Exactly, negative 2y plus 1. Is that okay? Anybody see anything interesting about these two denominators? Even though they're not common denominators, they are what? How about Patty? They're opposite of each other, right? We got positive 2y here, we got negative 2y. We got negative 1, we got positive 1. So if they're opposite of each other, there's a nice trick we could do so that, you know, we could kind of make a common denominator. Anybody see what we could do here? How about Spencer? Yeah, what do I do with the negative 1? I multiply it. Yeah, I could do that. Or could I factor out a negative 1 too? It sort of does the same similar thing. So can I factor out a negative 1 from the denominator? Yeah. If I do that, nice thing happens. Well, everything else remains the same, right? I get 2y over. If I factor out a negative 1 from 2y plus 1, what do I get? It becomes negative 1 times what, Jason?
2y minus 1.
2y minus 1. And we like that, don't we, guys? Because not only do we want the first terms to be positive, if you do this, we happen to get a common denominator. And it's kind of nice that we have a negative 1 out here, don't we? What is negative 1? If I were to move this negative 1 out from the denominator, I get negative 1 over negative 1. What is negative 1 over negative 1? 1. So doesn't that become just 1? And now we get what we wanted here. Isn't that nice? So we got 2y minus 1, 2y minus 1 here. So we have a common denominator. Do you see what we did there? Okay, now all we have to do is add the numerators and we're done. Okay, so whenever you have a denominators, right, you first change it to standard form if it's not in standard form. And if you notice that they're totally opposite of each other, factor out a negative 1, right? So that the first term is positive. A leading term is positive, right? And then things will work out nicely. So what's the answer? How about Paige?
You get 5 plus 2y over 2y minus 1.
Exactly, I get 5 plus 2y over 2y minus 1. I don't like the way 5 plus 2y is written. It's not standard form, is it? So let me rewrite it as 2y plus 5 over 2y minus 1. That'll be the correct way to write it. Okay. So how many people got this? 2y plus 5 over 2y minus 1. Do you see how this one works? Why do you think I put a star on this one here?
All
Yeah, because the denominators are opposite of each other. When you have that, just factor out a -1, okay? All right? Good. The question is it okay for us to cancel out these two y's together since they're, right, same numbers and so forth? Is that what we could do here? No, why not? Why can we not cancel out 2y and 2y? That's a great question. Why not? We just talked about this. Who could tell me? Chuck, why can I not cancel out the 2y and 2y? They look really nice.
Because you can't cancel it out because you have to do it on both terms.
Yes, 2y needs to be in both terms. In other words, whenever you cancel things out, you have to be able to factor those. Can I factor out a 2y from the numerator, the whole numerator? No. That's just part of the numerator. Can I factor out a 2y from the whole bottom? No. Remember that was the third step. When you cancel things, you have to be able to factor, then simplify. We can't factor 2y from the numerator, can we? It only belongs to the first term. Do you guys understand? So whenever you cancel things out, don't just do it because you see 2y and 2y there. That's it, right? You could only do that if it's a factor of the whole numerator, or if it's a factor of the whole denominator. Right? Then you could simplify. That's a good question, guys. Okay, so don't cancel those out. They'll be wrong. Okay, so don't write like 5 as your answer. Okay, they'll be wrong. Any question? Do you see why you can write 5 as the answer? Okay, because you're dividing top and bottom by 2y, right? You don't have 2y as a factor of the whole numerator, right? You only have 5. Yes, 2y goes into 2y once, but does 2y go into 5? No. 2y goes into 2y, that's fine, but does 2y go into -1? No, that's why you need to factor first, then cancel. Okay? All right, let's move on to the next example. Here's example 4. 12 over mn squared minus 5 over mn.
What?
This time, we don't have a common denominator, LCD, least common denominator. But it's pretty straightforward to, it's pretty simple to, right, rewrite these fractions so that they have a common denominator, least common denominator, right? Everybody go ahead and try. Okay, I'll wait. How are we going to change? What is first of all, our LCD? That's what you gotta. Okay, let's do that first. What's the LCD going to be? This. It's sort of nice. You don't even have to factor the denominators because they're already factored, right? Anybody see what the LCD for this is? How about Samuel Park? Mn squared will be your LCD. You guys remember? M and n are the factors that were used, and we choose the highest exponents, right? To make sure both of these fractions goes in. So what do we need? Well, for first fraction, it already has mn squared. You don't have to do much. What about for the second fraction? What do we need to do to the second fraction so that it has mn squared as its LCD? Camila? Multiply n to both numerator and the denominator is exactly right. Can I just multiply n to the denominator? No. That would be wrong because
That'd be 1 over n.
exactly it would be 1 over n. You don't just multiply all of a sudden to a number 1 over n, right? It will not have the same value. So it's got to be n over n. What's n over n?
1.
Basically 1. So you can multiply 1 to a fraction. It doesn't change its value, does it? So that's why we're doing this. Okay, so when we do this, Chris, what do I get? So I get 12 mn squared. That stays the same, doesn't it? Okay. Let's change it to addition. Plus -1 times what, right? -1 times what? 5 over, exactly. Are we okay there, guys?
Yes.
Okay. Do you see how I changed to addition and it became, right, -5n because it's really multiplied by -1, right? So, is that okay? Go ahead, everybody then finish up. Shouldn't take you too long. Okay. We're almost done. All right, so who could tell me how about Brandon? Exactly, I get -5n. Good, you wrote it as a standard form. -5n plus 12 over mn squared. How many people got -5n plus 12 over mn squared? Any question? Guys, can I cancel out this n right here and n squared over here? No, right? Because n is not a factor of the whole numerator, is it? Right? We weren't able to factor that because n doesn't belong into the, right? We don't have n in 12, right? Only time you could cancel is after you factor out those factors. Then you can simplify. Is that okay, guys? Please remember that, right? Many times people do all this work. At the end, they just cross out n and n squared, right? They write negative 5 plus 12 over mn or something like that. That'll be wrong, okay? You can only cancel those out if those are factors of the whole numerator and the whole denominator, okay? Cannot stress that enough, okay? Many times people do all this work, at the end they just cancel things out because they just see the common factors. We're thinking that they're common factors, but they're not really common factors, are they? Of the whole numerator and the denominator. All right, let's move on to the next example. So here's a nice problem. Y over 6y minus 2 plus 4 over 3y minus 1. Do we have an LCD right now? Least common denominator? No. So guess what? We have to figure out what the least common denominator is. And remember what we said? In order to find the least common denominator, what do we need to do with these denominators? Eunice, do you remember? Look at your notes. What do we say? The very first step. To find LCD, what do we have to do? We have to look at your notes, very beginning, step 1. Factor what? Factor denominators. Could we factor 6y minus 2?
Yes.
Yes, we can. What does that become? Mimi?
3y minus 1.
Right, 3 times y minus 1 is exactly right. Now that we've factored our denominator, do you see what our LCD will be? Yes? What's going to be our LCD here? How about Lynette? What would our LCD be? Now that we factored the denominator, it's easy to see. Yeah, it's going to be 2 times 3y minus 1. Correct? So all we have to do is multiply the second fraction by what? 2 over 2. You guys get that now? Then you would have a common denominator. Go ahead, everybody try. I'll wait. Okay. So help each other out too. That's fine. Okay. All right. So who can tell me what to do next? How about Aiden? Now that we have a common denominator, oh, we don't have common denominator. What do we do to get?
Multiply the 4 over 3y minus 1 by 2.
Exactly. 2 over 2. Very good. You need to multiply the second fraction by 2 over 2 so that you have a common denominator of 2 times 3y minus 1, and that's what we get. Right? I mean, of course, 4 times 2 is 8, right?
Yeah.
All right, so what do I do? How about next? Carolyn, what do I do next?
Y plus 8 and then 2 over 2 y minus 1.
Exactly. So we get y plus 8 over 2 times 3y minus 1. Should I multiply this 2 to the 3y minus 1?
No.
Yeah, you could do that, that's fine. But remember, for these fractions, I want you to leave it factor. The denominators, I like it factored actually. Okay, it's fine. Because you could cancel things out or, do something else with it too. So it's okay for the denominator to be factored. I like that. Actually, as a matter of fact, I want the numerator and the denominator to be factored because, you could simplify further later, right? So it's a good idea to have it factored, right? Okay, any questions? Are we good?
Yeah.
Can you do something like this for your homework tonight? Let's do a couple more. Okay, let's do the next one here. Let's work on next. Okay, so if you got the rest of the examples, you could add and subtract 3 fractions. It's the same thing, right? So we got 3r plus 4 over 6 plus 4r over 3 minus r minus 2 over 4. Okay, so we have the denominators as 6, 3, and 4. We could actually do a factor tree and factor all the denominators and so forth, but these are pretty simple. Anybody see what the LCD will be without doing all the factor tree and all? How about Livy? Do you see what it might be? 12. It's going to be 12, right? Do you see that? So what do I need to do with the first fraction so that I get a 12 as my denominator? How about Jenny? What do I need to multiply the first fraction by so that you would have a 12? 2. Just 2 or 2 over 2? 2 over 2, exactly right. So I need to multiply the first fraction by 2 over 2. What about the second fraction? Royce, what do I need to multiply the second fraction so that I get a, LCD of 12, I need 4, right? Of course, it's 4 over 4. What about the third fraction? Brianna? Three over 3 is correct. Right? And notice how I change it to addition first. Right? As I'm doing this, I changed the last fraction is subtraction, so I wrote it as plus -1 times this whole thing, right? You see that? Okay, go ahead, everybody finish it up. I'll wait. You should all be able to get this right, okay? And of course, work as a group if you're done. Help each other out too. All right, who can tell me what to write next? How about Aaron?
I got 6r plus 8 over 12.
Okay.
16r over 12.
Okay.
Plus 6 or negative 3r plus 6 over 2.
So first, I need to multiply them out. I just multiplied 3 times r minus 2, then I distributed. And you got what? Did you get negative 3r plus 6? Because that's what you should have gotten. Thank you.
Yeah.
Okay, good. Did you all distribute that negative to both of the terms? Yeah? You could have first multiplied by negative 1, then multiply by 3, or just do it the other way, same thing. Either way, you should have gotten negative 3r plus 6. Yes? How many people got negative 3r plus 6 for the last 2 terms? Good. Over 12, of course, because you have a common denominator of 12. Then, of course, when you add them up, Joseph, what do we get? 19r plus 14 over 12 is correct. How many people got 19r plus 14 over 12? Okay, not all of you. Not all of you.
Oh, I got it.
Okay, most of you now. Go ahead, and if you didn't, go ahead and fix your mistake. Do you see your mistake?
Yes.
Go ahead, fix it now. I'll wait. Okay. Did anybody left it as negative 6 at the end here? Because if you did, you would have gotten positive 2 here. Right? That's how you get that wrong. Because you have to distribute the negative 1, right, Aiden? You see that? Right? You got 2 terms, right? Negative 1 times is 2 terms. Any questions? Easy enough? Yes? Pretty easy? Okay, good. Okay, why don't you try example 7? Here you go. It says 2x plus 4 over 5 minus x minus 1 over 4. And we could already see what the LCD will be. What's going to be the LCD, class? 20. Go ahead, everybody try. I'll wait. Okay. Alright, so we said the LCD was 20. Eugene, what do I need to do then?
You have to multiply the left fraction by 4.
Good. 4 or 4 over 4?
4
4 over 4, okay. And then what about the second fraction?
by 5 over 5.
By 5 over 5 is correct, okay. And I notice I changed the addition in the middle, alright. Okay, so who can tell me what to write next? Samara? Right. Right. So tell me what does the numerator of the first fraction become when you multiply 4 over 4? Good. I get 8x plus 16 over 20. Good. Plus negative 5x plus 5 over 20 is correct. Did you all get? Yeah. Negative 5x plus 5 over 20. Did you all get that? Question?
Aren't you supposed to factor it, like, into the numerator in the first one?
Right. You could, but then because I want to add all the numerators together, you factor at the very end. Because we want to make these 2 fractions with the LCD, right? You want to multiply these out, and then you want to gather all the like terms anyway. So you have to distribute that later. You could leave it factor, but then you're gonna have to multiply it anyway, right? Because you have to gather all your like terms. All right, good. Next, what do I get here, Angel? 3x plus 21 over 20 is correct. How many people got 3x plus 21 over 20 as the answer? Very good. Now, did anybody factor the numerator? Because you could, yeah, so me too. And I did, so you get 3 times x plus 7 over 20. Does that help us to simplify further? No. Not really. 3 doesn't go into 20, so, right? So you could just leave it this way, or leave it this way if you, but it's sort of nicer. Yeah, leave it factor, right? Because it's better this way, because what if the denominator was like 21 or something? Then 3 will go into 21 and you could have canceled those out, right? So it's always good to factor, right? The numerator and the denominator, right? Because, right, it could be that those things cancel out, those factors. Does that make sense? So, yeah, good thing if you wrote it as 3 times x plus 7 over 20. Yeah. Any questions? Are we good?
Yeah.
All right, good.